On a hot day, a steel bridge becomes slightly longer. You cannot see the change from a car, yet the bridge was built around it. That narrow break between deck sections is not unfinished concrete, and it is not automatically a crack. It is empty space deliberately left where a rigid structure needs permission to move. The paradox is simple. Sealing that gap can make a bridge less reliable, not more continuous. So what is that missing strip doing while thousands of vehicles cross it? Steel is made of atoms held in a repeating structure. Heating gives them more energy, so their average spacing increases a little. Cooling brings them closer again. The movement over 1 meter is tiny, but a bridge deck can be hundreds of meters long. Small changes repeated across that distance become millimeters or centimeters of movement. Engineers therefore ask not whether the deck moves, but where that movement is allowed to go. This is not steel stretching like rubber. It is a stiff steel-end concrete system changing length slowly as its temperature changes. If that movement is restrained, the force does not disappear. It travels into the deck, supports, and end walls. Imagine a metal ruler pressed between two immovable walls. Warm it and it wants to become longer. A bridge is more complicated, but the same principle applies. Good design chooses a route for the force before the weather chooses one. The visible gap is usually an expansion joint. It spans a controlled opening so tires can cross while deck sections move. Some joints use shaped steel plates, some use flexible seals, and some are designed for railway tracks. Their forms differ because a highway deck, a rail bridge, and a pedestrian bridge face different loads. But each joint has the same job: make a moving boundary safe to cross instead of pretending the boundary does not exist. Below the deck are bearings and supports. A bearing can carry enormous vertical weight while allowing a small sliding or rotating motion. One support may hold a bridge in a chosen position, while another lets it move in a controlled direction. The joint above and the bearing below work as one mechanism. Drivers notice the line in the road. The bearing is the quieter component that gives the deck somewhere real to go. On a sunny afternoon, dark steel can heat faster than the air around it and the gap may narrow. On a cold morning, the same gap may widen. Engineers calculate a range of temperatures, bridge length, material, and local climate rather than designing for one average day. A changing gap is not automatically a failure. The useful question is whether the designed route is clean and operating. Aligned joint surfaces, working seals, clear drainage, and bearings that are not jammed. Expansion joints take repeated impacts from traffic and exposure to water, grit, salt, and vibration. They also need to direct rain away from vulnerable concrete and steel below. Inspections therefore look beyond the opening itself. They check deck edges, seals, drainage, bearings, and signs that movement has changed from the design. A thump over a joint can be normal. A broken edge, blocked drain, or seized bearing is a reason to inspect the mechanism, not a reason to erase the gap. Not every bridge uses the same joint. Short bridges, long continuous spans, curved decks, and rail bridges all need details matched to their support arrangement and temperature range. What drivers see is only the surface of a longer calculation. The final answer is that the gap is not a weakness cut into a bridge. It is a controlled boundary. In a rigid structure, carefully planned space preserves shape by giving heat, cold, and traffic forces a route to go.